Starting, all attendees are in listen-only mode.
Good morning, everyone, and welcome to the second ETP4HPC webinar. I am Pascal. I'm ETP4HPC's Communication Manager, and I'll be your host for this session and the timekeeper as well. I have two colleagues to help running the show. Martin will handle your questions. I think you can probably see him among the presenters. And Maike is handling the chat. I know she's already chatting to you. Someone remarked during our previous webinar that I introduced myself and my colleagues, but I did not introduce our association, ETP4HPC, for those of you who are not familiar with us, so I'll do that very briefly now. ETP4HPC is a non-profit association that promotes European research and innovation in high-performance computing, HPC. We are a private member of the Euro-HPC joint undertaking. To make it simple, that's the organization in the European Commission that addresses HPC. And we propose research priorities for Europe in the area of HPC, of course. So to be clear, we propose research areas that should be funded. Before we start with the real content, well, you've probably noticed that this webinar is in listen-only mode. The webinar is recorded, and if you want to play it back, you will receive the link to the recording later today. On your computer desktop, you should see on the right-hand side the GoToWebinar control panel that's illustrated here. You can use it to participate to this webinar. We won't use the hand-raising feature today, but you can ask questions or send remarks. I mean, it's called questions, but you can send remarks too in the question pane. Feel free to submit questions at any time during the presentation. Martin will answer right away if possible, and otherwise we will answer questions of common interest in the Q&A session at the end of the webinar. Finally, you can download handouts, and today they include today's presentation in PDF, and I have also put the Handbook of European HPC Projects. That's a catalog of all ongoing European funded projects in HPC. We have a busy agenda today with lots of speakers. So I think they've all turned on their video so you can see them now. Hello, everybody. Thank you for being with us today. We're going to have a series of short presentations. Our objective is to give you an opportunity to know who are the members of ETP4HPC and to give you contact points if you want more information, or maybe if you have an idea for a collaboration. Oh, thank you, guys. You can turn off your video. We will subsequently have only the video of the person who talks. Before we start, I had a question for our audience. We have a lot of SMEs in today's agenda, and actually SMEs are 40% of ETP4HPC members. So I was wondering if among our audience today, we have the same proportion of SMEs. So normally you should be able to see the, no, it doesn't work, okay. Can you see the poll? No, it doesn't work. Can't see the poll. Well, too bad, forget about the polls. That's the demo effect, you know, it's not working. So we'll do that later on. I will send a questionnaire. So then we'll start on our agenda. Today we are going to meet 3 of our new members. Then we will meet the 4 SMEs that were supposed to exhibit on our booth at ISC. And then we have 5 questions to projects DEEPEST and Mont-Blanc 2020. So we will start first with our new members. Welcome. So today we are welcoming 2 SMEs, AGENIUM Scale from France and Do It Systems from Italy, and also an association, EOFS. So first speaker is Guillaume from AGENIUM. Guillaume, you ready? You have 5 minutes.
Okay, thank you. So we can go to the next slide, please. Next slide. Can you hear me?
Yes, I can hear you.
Can you go to the next slide, please?
Yeah.
Okay, thank you very much.
Sorry, sometimes it takes a few seconds.
Okay, so we basically, before we were known as Numscale, and then now we are part of a larger group which is called AGENIUM. We are based on Plateau de Saclay in France. So what we do basically is we do optimization. We do low-level optimization. So we know how to work with CPUs, GPUs. We work a lot in the field of HPC, of course. As you can see on the right, we mainly do C, C++, but of course we can do other languages. We know other languages. We are able to work with a lot of chip vendors like ARM, Intel, PowerPC, NVIDIA, of course, AMD. So what we do is we like to work at a really low level. So I will explain a bit later. So next slide, please. Thank you. So what we do, so we have different services. So we can so what we sell the most is diagnosis. So what we do is we profile applications and we find bottleneck, and we either do reports or we fix the bottleneck. By fixing, I mean we improve the performances, and so we deliver this to our clients so our clients have better running times and this kind of stuff. So this is the main service that we do. We also do modernization of code. So often we are asked to work on Fortran code, all C code, all C++ code. So what we can do is modernize the code to take advantage of recent compilers, recent advances in many areas, recent libraries, whatever, so that the code can run faster. We also port source code from one language to another. So this is kind of related with modernization, but it can be distinct. So we also port codes from a system, an OS to another, usually from Windows to Linux. We can also work with less known operating systems. And finally, what we do also is we write custom software. So we begin with a blank page, and basically what we do is NKD or a folder, and then we start working. So we start from scratch basically. So next slide, please. So what we did recently. So we signed a partnership with Microsoft to work on Azure. So what we do in this is we improve software from Microsoft clients in Azure. So they mostly run on Linux or in Azure. Wow. And so we have also a library which is called NSIMD, which abstracts SIMD programming and also GPUs. So the goal of the library is to have a single source code which is able to compile and run for GPUs and CPUs. And so to prove that our approach works, we have put NCMD in GROMACS, in FESpec, which is a kernel developed in France at BRGM, which does simulation of seismic waves, propagation of seismic waves. And we also wrote Monte Carlo for the finance world from scratch using NCMD to prove that the library works. So the library is open source. You can fetch it via GitHub, and contribution welcomes. So that's 5 minutes. I'm done.
Yeah.
Thank you.
Thank you, Guillaume. Lots of potential collaborations here, I think. So now we're going to welcome our new member, Duet Systems from Italy, represented by Roberto Strano. Roberto, are you here? please unmute yourself?
Can you hear me now?
Yeah.
Okay, perfect. Okay, great. So I'm Roberto Strano, one of the founder of DEEPEST Systems with Roberto Minelli. And you can go to the next slide, please. Okay. Okay, we started our knowledge on the HPC system in 1991. Roberto Minelli started the knowledge on the HPC system in 1991 at Fiat Research Center. And then in 2010, we found the DEEPEST system. Our specialization into this to provide services in the HPC field. So we normally do the hardware installation of the HPC system. We do the software installation of all the infrastructure software of the HPC, and then we do the post-installation support from the hardware layer to the software layer and to the user software. At the moment, we are the main providers of services for HPC services in Italy, and we're going to move also in Europe to do HPC services. As I said before, what we normally do, we collaborate with other vendors like HP, Dell, and so on. We provide the installation of what they sell. So they sell an HPC solution to a customer, and then we go there and then install the hardware. We install all the software stacks and also the user software. And then after that, we provide the support to the hardware layer and then also to the users. So if the users have some problem to use the software on the cluster, we normally do the support to them. Next slide, please. Okay, we got two offices. The main headquarters is in Turin, and is the headquarters. And we have also a branch office in Maranello, because one of our clients is Ferrari. And we are going to open a new business, a new company in France in a few months. Next slide, please. Okay. At the moment, we have 42 employees, almost all focused on HPC services. So maybe, let me say, the 19% of the employees is focused on HPC services, and we are still hiring people because we have so much work. So we need to hire more than 42 employees. Next slide. Okay, as this is our service portfolio. So what we normally do is design the solution with the hardware vendor if it needed, or with the customer, and define the solution. Also define which one is the best, for example, the best queue manager or the best file systems, and also we configure all the system to work better together. So we design the solution, we install the solution. So we install all the solution from the rack stack to the software layer, all the infrastructure software like queue manager, like file system software, and so on, parallel file system, and then we support the users. We do also the HPC benchmarking if the customer needs to benchmark some solution, or to have an idea of what the solution does. We can do also benchmarking.
1 minute
we
to
do
go.
also okay. We do also training and license monitoring for the HPC. Next slide. This is our partners. So just a slide. Next slide. We are the second level support for all Europe for PBS Pro. Next slide. So those are our contacts and our websites. If you feel free to contact us for any other question or information. Thanks a lot.
Thank you, Roberto. And if you have questions, you can also ask your question online, and we will forward it to Roberto. So now we're moving to Germany, yeah. So with the EOFS Association presented by Frank Bethke. EOFS is a European association like us, and I think we have a number of members in common already. Your turn, Frank. You're on mute. Frank, are you here?
Can you hear me?
Yes, we can hear you.
Okay. Good. I'll give a quick update about the European Open File System Organization here, and please move to the first slide. Quick overview. EOFS, as you said, is an association. It's not a company. And it's interesting because it was one of the first to be founded as a Societas Cooperativa Europea. That's Latin, and that's a special legal format based on European law that happened in 2010. So we are now 10 years old. You see the governance structure here. So I'm the chairman of the board and the president. And you see we have a government organization that comes from members across all Europe. You also can see a couple of widely known names being our members here. And we do the following. Next slide. The objectives. So the objectives of EOFS is to promote the establishment and adoption of open source parallel file system, enhance its quality, and specifically ensure that requirements of European organizations, institutions, and of course, companies are upheld. Now, when EOFS was founded in 2010, the key parallel file system at that time was Lustre. It's still true today. And again, we only talk about open source file systems here. And many of you may remember that at that time, Lustre was in a very, very critical phase. Its future was unclear, ownership was unclear, and it was unclear who and how many source trees we will have in future. So one of the objectives at that time was to stabilize Lustre, and I think that objective was met. We did quite a good job here. For further information, of course, we have a website that's mentioned here. And since then, EOFS, together with our, let's call it, sister organization, OpenSFS in the United States, we have been organizing highly successful focus sessions, typically called BOFs, for Lustre, and also another open source file system, BGFS, at the annual ISC and SC conferences. And of course, we actively participated and continue to do so in the key events associated with file systems. One is the Lustre user group, the other one is the Lustre admin and developers workshop. You know, one takes place typically in the United States and the other one over here in Europe. And we are open definitely to other related open source products and projects as long as they are associated with parallel file systems. And we plan also in future a working group focusing on specific European requirements in the context of European HPC and exascale projects like Euro HPC. That's clear. Next slide. Major accomplishments. That's quite interesting because last year, end of last year, we signed a pretty complex legal contract with the organization OpenSFS and the previous owner of the Luster trademark, Seagate. And so what happened is that basically Seagate sold the trademark Luster and all its related assets to both at equal share OpenSFS and EOFS. So what that means is that Luster is still the leading parallel file system in HPC, especially at the high end. 50% of the trademark and all its related assets are now owned by the European organization, and that's EOFS. So let me close by saying that all organizations and of course companies with an interest in Luster and its further development, but also other open source HPC file systems, are invited to join our association here. You can acquire a share, you'll get voting rights and participate in further projects. Annual fees are low. If you're interested, you can contact me or any other member directly. Thank you very much.
Thank you, Frank. If you have questions for our speakers, please enter them in the question pane, and we'll now move on to our next item in the agenda. Last week, we should have been in Frankfurt at ISC, hosting 4 of our SME members as co-exhibitors on our booth. That's what we did in 2019. It was a great experience, I believe. Well, COVID decided against it, so nothing can replace our booth at ISC as a meeting and networking place, but we created a virtual showcase page on our website with short videos from our 4 co-exhibitors. So I hope you visited it. It's still available. If you go to our website, there is a pointer from the homepage. And today we have invited those 4 SMEs for a live presentation, short presentation, but live presentation. So welcome to Bright Computer, Constellcom, NAG, and Submer. So we will start with Bright, and our first speaker will be Terry Rush from Bright Computing. Terry, the floor is yours for 5 minutes.
Okay. All right, thank you. Starting now. Can you go on to the next slide, please? Thank you. My name's Terry Rush. I'm a sales director with Bright Computing. High performance computing is probably the most dynamic and exciting sector of the IT industry, with constant innovation and change. Ever since the early Beowulf Linux clusters were first developed, compute vendors have focused on making their systems more sophisticated and more efficient, with faster CPUs, faster data movement, lower power usage, etc. But nobody was really focused on making all of these different pieces work together in an easy to manage way. It would often take many days or even weeks to turn racks full of hardware into a production supercomputer using open source software tools, which were often underdeveloped and unsupported, as well as being difficult to make work together. Deployment deadlines were often missed, causing budget overruns and penalties. Once the supercomputer was finally accepted, the ongoing management and monitoring was again placed in the hands of unsupported open source software tools. This approach is like putting cheap tires on $1 million racing car. So Bright Computing was formed to reduce the time, complexity and risk when building and managing clustered supercomputers. Bright Cluster Manager was launched in 2009, and since then has been adopted by over 800 customers worldwide, including many of the world's largest manufacturing and pharmaceutical companies, research labs and academic institutions. Can we go to the next slide, please, Pascal? Traditionally, on the left side of this slide, HPC was a single vendor, multi-platform, on-premise environment designed to do a narrow range of modeling and CFD applications. Mixed workloads in areas like academia, supporting multiple departments, commercial companies running seismic processing, genome sequencing, all created these additional management problems. Bright Cluster Manager was developed to build and manage these supercomputers and has been continuously developed ever since to accommodate the changing HPC landscape. Today, on the right side of this slide, HPC is a far more complex and varied industry than it was just a few years ago. In place of monolithic single-use on-premise machines, many supercomputers now comprise a mix of processor technology from multiple vendors, running a wider range of applications, including data analytics and AI, as well as more advanced and demanding simulation and processing applications. Compute resources may reside not only on physical hardware, but also in a virtual environment. HPC in the cloud is becoming more widely used, and the ability to automatically expand a supercomputer into the cloud to accommodate unpredictable usage is becoming a more common requirement. Bright Computing has continually developed its cluster manager platform to accommodate all these new demands. As well as the building and routine monitoring of an HPC environment, Bright Cloud Bursting can automatically create or expand clusters in a virtual environment and can reduce cloud costs by closely managing data movement and resource usage. Bright Edge enables remote sites to be managed from a central location, so risk is reduced and cost is controlled. Those remote sites could be individual servers instead of clusters, or even IoT nodes, where thousands of sensors or controllers spread all around the world could be easily managed from a central location using Bright Cluster Manager. The usage of containers is increasing, but deploying them reliably is still difficult. Bright Cluster Manager for Containers enables the deployment and management of container orchestration tools like Kubernetes to be easy and reliable. Next slide, please. Pascal, high-performance computing is continuing to develop at a fast pace, and its use is spreading way beyond the traditional scientific and niche industrial applications. HPC enables us to build greener products, such as more efficient batteries for cars, aircraft that use less fuel. By understanding the world's climate better, we can predict storms more accurately to save lives and use renewable resources more effectively to power our planet. As these use cases expand, HPC does not become easier, it becomes harder. It's harder to build and manage all these separate hardware and software elements needed to satisfy these new and growing demands. Bright Cluster Manager provides a fully supported, mature and stable HPC management platform, which makes it easier to manage these complex compute environments. And in doing so, makes it easier for us all to enjoy the results of this exciting new era. And the final slide, please. Thank you for your time. We'd love to answer any questions you have at the end of the session, and do visit our very informative website at brightcomputing.com. Thank you.
Thank you very much, Terry. Thank you for the presentation. And again, please send your questions to Terry. Our next speaker is going to be Nicola Tonello for Constellation. Nicola, you were on our booth last year. I really missed the interaction. Welcome, you have 5 minutes.
Thank you very much, Pascal. Yeah, my video is now working. So yeah, first of all, thank you, Pascal. Thank you, ETP4HPC. We're all working in a new environment, and you're making the best of it. So thank you very much for that. It's appreciated. So I'm CEO and founder of Constellation, and I will try to present to you globally what we're about and what we do in the few minutes that we have. If you could go to the next slide, please, Pascal. So I will steal a line from Terry in the previous presentation. He used that very good line about hard and easy, and we come from a similar perspective, but at a different level, not the hardware level. We founded Constellation as a consequence of experience, mainly for myself in the CFD field, of finding HPC resources difficult to access and then not so easy to use. And expanding on that, we recognized that this was a fairly common problem, and that people who actually could use HPC often did not know where it was, how to go about getting an account, and then how to actually use these machines to carry on their work. I think it was a presenter last year at Supercomputing who said, when you have a PhD in chemistry, you shouldn't need a PhD in computing just to be able to run your simulations. So that's the angle that we come from, and one of the problems we're trying to solve. On the other side of that is also the aspect of management, user management, project management, and user acquisition for HPC centers. And we concentrate on HPC centers, so national facilities such as the Hartree Center, whom we work with as a partner in the UK. And often what we find is that the HPC centers have absolutely superb machines, superb computing skills, but may not necessarily be able to really translate this into something that's directly of use to a regular user. So we work with them as a bridge for that, and we also offer them a way of managing the systems in a simpler way, less time consuming, so that they can actually concentrate on what they are very good at. So our answer to these problems is a web accessible platform that we call Constellation. And if you could move to the next slide, please, Pascal. So Constellation is divided into two different products. Enterprise Constellation, which is the part that end users are actually using. And the point of the platform here is to give this use of access that I've been mentioning, ease of use, speed, collaboration, and an increased productivity, with also a lot of visibility. So users are able to see everything they use. They can make budgets. They can look at their quotas for the different projects, etc. A very, very important point with that as well is that it's completely self-managed. So once users have acquired an account, they can then create their own users, their own projects, etc. And it's removing having to ask for permission to do everything and having to contact HPC centers directly. The platform has been conceived from the beginning to be application agnostic, so you can run any application that you want. Of course, it needs to be installed on the machines, but we can do that for you, or we can work with the center for that in order to do that. And in the words of one of our corporate customers, they found that the tools and the apps that we made available for them for their workflows translated it to increased productivity, and they liked the fact that they could actually run their apps and get results just with 3 clicks. The other product is Constellation for HPC centers, and here the point is to help administrators of HPC centers, and so people can use the platform for management, monitoring, to create projects, to see who's using what on the machines, to do the accounting as well. And it provides also very good tools for business development people, and it basically gives an effortless user acquisition and support system, because all you need basically is a tablet, and you go to a prospect and you can show them straight away what it would be like for them to have access to the system. And it's a way of maximizing utilization. If you want to go to the next slide, please, Pascal. So thank you very much for your time, and please do visit our website, and do not hesitate to contact me or the general email address, or to call us if you'd like more information. We'd love to hear from you for any questions, comments, or to give you a demo. Thank you very much.
Thank you, Nicolas. Thank you very much. So we're staying in the UK, I think, for our next presentation. So welcome, Mike Croucher from Numerical Algorithm Group. Mike, are you ready?
I'm ready, yes.
5 minutes again.
Okay, thanks very much. Can we go to the next slide, please?
Here you are.
Thank you. So we are the Numerical Algorithms Group, and we were founded in 1970. So we have been around for 50 years now, which is a a long time for any company, but I think it's something that we're particularly proud of as a technical company, as a technology company. So we started off in UK academia, and we've got offices in the UK, US, and Japan, and we've got customers all over the world. Now, if you know about NAG, you may know about our NAG library, which is our primary product, or our Fortran compiler, but we've got various other products as well, such as an algorithmic differentiation solution, and we've got a new partial differential equation toolkit that's currently in beta. And we provide several services as well, and the one that I want to talk about today is our relatively new cloud HPC migration service. So can we go to the next slide, please? So the fact of the matter is that various companies and academic institutions and so on are moving their HPC workloads to the cloud. They have various questions, including should we do this? And if and when they decide that they should, then they want to know what's the best way of all the different options, and crucially, how much is this going to cost, and how do we minimize those costs? So if we can go to the next slide, please.
Ah, sorry.
It's okay.
Oops. Oh no. Sorry, something. The
okay, thank you. So as a concrete example, this slide represents a larger piece of work. Oh, previous slide, please. Thank you. So this slide represents a larger piece of work that we've done relatively recently, where we looked at a reverse time migration code that is a typical workload in oil and gas. And if you were to lift and shift that, an example problem from an on-premise system to the cloud in the most sort of naive way possible, you replicate exactly on the cloud what you have on your HPC system, or as near to exactly as you can, you know, then the resulting problem costs something like $3.9 million to solve. The cloud offers the ability to optimize the HPC system to fit the problem, which is something that we never really had the chance to do with on-premise systems. And there are various ways that you can do this, and they come in at different cost points, as you can see here. One of the points that I like to point out on this slide is that if you compare solution 1 to solution 2 there is actually solution 1 with the addition of more resources. That is, the per hour cost has gone up, but the overall cost of solution comes down by quite a substantial amount. And that can be counterintuitive to some, because by adding more resources to a solution, by making the hourly cost go up, you can bring the cost down. And so you need skilled HPC expertise combined with cloud knowledge to help you formulate the best solution, and that's where we come in. Next slide, please. So NAG, I've got various services that can help with the overall cloud HPC migration workflow. So as well as optimizing cloud resources in the kind of manner that I showed on the previous slide, we also have got a very experienced HPC optimization team. We're part of another European project called POP, Performance Optimization and Productivity, for example. So we've got lots of experience of HPC optimization. Using accelerator technologies, and we port code to GPUs and other types of accelerator technology. And when you work for a company that's called the Numerical Algorithms Group, as you might imagine, we've got a lot of experience in developing new algorithms. And one example is how we introduced algorithmic differentiation to finance to speed up their compute kernels by factors of 30 or so. Next slide, please. So the important thing here is that, you know, the cloud is great, it's exciting, but we like to say that you need to be careful not to fall for all of the cloud marketing. It's not quite as easy to use as the cloud vendors make out. It's the software and infrastructure change takes a lot of effort and investment to keep up with everything, and NAG can help you do that. If you go to the next slide, please. So we have got a new service offering, a HPC cloud migration service. We focus on the cost to solution, along with optimizing your application to the cloud. And one of the important things here is that we're completely cloud agnostic. We've got we're partnering with all of the big 3 providers, and we've also got initial conversations going on with some of the smaller cloud providers. So we don't just work with Microsoft or Azure, we work with pretty much everybody. So there's our website there. Feel free to get in touch either with me directly or by contacting us at NAC. Thank you very much.
Thank you. Thank you very much, Mike. So for our last SME, we travel to Spain to meet Submer, presented by Raúl Alvarez. Raúl, are you with us?
Yeah, I am here. Can you hear me well?
Yes, we can hear you.
Okay, nice. So yeah, hi everyone. My name is Raúl Alvarez. I'm solution architect at Submer. So I would like to explain how we at Submer are working to enable the next generation of high-density HPC solutions. As Pascal mentioned, we are based in Barcelona, but we have offices in Palo Alto in California. So if you can go to the next slide, please. Okay, so as you may know, Submer's core technology is liquid immersion cooling, and our main product is the SmartPod. The SmartPod is basically a rack-based format tank filled with a proprietary dielectric and thermal efficient liquid, where the IT hardware is immersed. So the thermal efficiencies exceed around 1,400 times on those on air. So the density that we can achieve go way over air-based solutions. And we are fully compatible not only with standard 19 rack form factors, but fully OCP open rack specification. So if you can go to the next slide, please. All right. So the active part of the system is the coolant distribution unit that has a server form factor and hosts a redundant pumping system, a heat exchanger with a highly sophisticated telemetry and monitoring system. At a very high level, as you can see in this slide, there's 2 fluid loops. On first instance, the coolant loop never leaves the tank, and it's coupled with a heat exchanger on the CDU with a cold water secondary loop connected to a highly efficient dry cooler to dissipate the heat. As the secondary cooling loop is just a water loop, the system can be easily hooked up to any existing heat reuse installation to reuse the heat, since we capture the 100% of the heat into water. So if you can go to the next slide, please. So a SmartPod-based deployment is simple and straightforward, and it doesn't require most of the standard data center infrastructure. This simplifies deployments and in a second moment, also maintenance. You can deploy mostly anywhere, saving up to 50% on CAPEX building costs, and that translates into 25–40% savings on the TCO. So the immersion environment allows for a significant increase in compute density, and not only that, the smart coolant, apart from dissipating the heat, protects the hardware from any dust, particles, vibration, etc., increasing its lifespan of about +30% and resulting in a less than 60% in failure rate compared to air-cooled solutions. So if you can go to the next slide, please. Okay, so I mean, our solution being rack-based, it's kind of universal. So with that, I mean that allows for off-the-shelf hardware to work in immersion with just minor modifications. And we have a really nice video on our YouTube channel showing how to prepare traditional cool server for immersion cooling. We've deployed and worked with the major hardware vendors as shown, but we are not limited to any of them. So we are working on the next challenge, standardizing high-density immersion optimized hardware design, allowing for unprecedented levels of density and performance. So if you can go to the next slide, please. So those are just some of the certifications that the company has received since its creation in 2015. In 2018, we won the 4YFN Best IoT Startup of the Year. So our technology is obviously ISO certified, and our smart coolant is non-toxic and really biodegradable, and has recently been awarded as food grade. and we are also members of associations such as OCP. We are active members of the subgroup dedicated to liquid cooling, DCA, and obviously ETP4HPC. So if you can go to the next slide, please. And yeah, well, that's all. Thanks everyone for your time. Summer is much more than HPC. Our vision is to transform traditional data centers and edge facilities into smart, lights-out, immersion-cooled data warehouses driven by robotics. And we are opening new frontiers in the next generation green data center. So please feel free to reach us at summer.com, contact@summer.com, or at my email address. So yeah, that's all. Thank you, Pascale. Thank you, the organization.
Thank you, Raul. And thank you very much to our 4 virtual co-exhibitors. We really hope we can welcome you on our real booth next year in Frankfurt. We've already reserved the booth. So now we move on to the big subject of the day. 5 questions to projects DEEPEST and Mont-Blanc. So my colleague Michael Malms will step in because he was the one who had 5 questions to Europrint projects. Michael, can you introduce our project?
Yes, sure. So that is very quick. So basically, DEEPEST and Mont-Blanc are running since quite a few years. So we're interested in getting the latest update. And in order to make these presentations not too long and similar between one and another, we thought, okay, so why don't we ask questions? And Pascal said the magic number is 5. So first question is, of course, in order to get going, we're asking, so what are the 3 most relevant results of the project? Talk about those for a few minutes. And since there is a lot of energy and focus on getting results on a very high TRL level of the recent Horizon 2020 projects, we would like to understand where are you with the TRL level, and what would be the next steps to, if this is not 10, what I assume for a research project can't be 10, what is it that you do to a high level? So the hidden question behind this is, how close are you to a production or quasi-production level? Yeah, what does it take to turn the results into commercial products? Then the next step, the next question basically is, so this is a research project, and it's important to get the results distributed, disseminated, and reused in products. So what are your major steps in promoting the use of these top results that you presented in question number 1? Number 4 is not asking you for your pet friends, for your friends you would like to collaborate with by name, but the idea is, okay, so are there verticals in the industry, for instance, industrial users, that you would like to work for? What is the set of ideal customers for you? You should know that the ETP has a working group, very active and working to attract industrial users to the association. And so in this context, it's important for us to understand, is there any desired link here? Can we as an ETP maybe facilitate in creating the network that you need? And then number 5 is, when you read through documentation issued by the EC or issued by EuroHPC, you see this topic as a major topic: European sovereignty, not only in HPC land, but in many technology-driven areas. And this is going to be of increased importance to show that you decrease the dependency of Europe towards technology coming from elsewhere. And the question is, how are you doing, and what are your steps in improving the independence and basically increasing, therefore, the European sovereignty. So those are the 5 questions, and I'm absolutely sure that Estella and Said have perfect answers. So let's go to them.
Okay, Estella, ready to share your slides?
As soon as you give me the presentation, yes, show my screen, and then I can. I hope you see my presentation now.
Yes.
Very good. Okay, so first of all, thank you very much to the ETP for inviting me to present here the deepest or some of the deepest results. I don't need to go again through the questions that Michael just perfectly introduced. And then I go directly to and try to answer the first one. So the first thing I need to say above all is that it's extremely hard to select the 3 top results on a project like DEEPEST, because we do hardware development, software development, and also applications. So it would be impossible to say which ones are the 3 top. What I try to do is to show 3 very relevant results, and in particular 2 which are more from general nature, and 1 which is very concrete, which is actually a product by one of our partners. And there are many similar examples in the project that I'm happy to introduce to anybody interested if you want to contact me afterwards. So the 3 selected ones is, first of all, system level architecture called modular supercomputing architecture. This is a heterogeneous system architecture that we introduced within the series of the DEEP projects. So DEEPEST is the 3rd one on a series of EU-funded projects. The second one is the software stack that has been developed in order to support the architecture. And the 3rd one is, as I said, a very specific node design that has been done by partner Mecware for this project and within it. So I go each one a little bit in more detail to the 3 selected ones. So the first is the architecture itself. So as I said, it's an heterogeneous approach. It's a different way of connecting heterogeneous computer resources in the system. Instead of building a monolithic system, what we do is we couple different compute modules, and you should understand one compute module as a cluster system of a relatively large size. So the architecture that is graphically displayed here on the right is containing, so it's actually the design of the prototype, the hardware prototype built within DEEPEST. And it contains 3 compute modules, which are the colorful ones, and 1 support module, which is the storage. So the 3 compute modules, the first one is the green, the cluster module. This is a cluster with 50 nodes of general purpose processors, so they are Intel Skylake. The booster, the so-called ESB, so extreme scale booster, contains 75 nodes, where the main compute power comes from NVIDIA graphic cards, so NVIDIA V100. And I should have mentioned, by the way, that the network on the booster side is European development called FabricCube, which is the XTOL interconnect technology. And on the cluster side, we had InfiniBand. So you see, we can couple modules, cluster modules, which are of different network technologies as well. And the 3rd one is the data analytics module, which is a smaller one, so it's 16 nodes, but it provides a high flexibility to the users. So here we have a strong CPU, we have NVIDIA graphic card as well, but we also have an FPGA. And the idea is that users, which specifically have do lots of data analytics, can use the accelerator device that they prefer, and there is also lots of memory, lots of non-volatile memory available for their data management. All the 3 modules are interconnected through a network federation, which is responsible to allow also to interconnect the individual networks of the clusters or of the modules, and therefore allowing for applications to run across these modules. So they are really interconnected so that the code could run, for instance, distributed between the cluster, the booster, and the data analytics module. And of course, also with access to the storage. Now, realizing this architecture can be done with different designs, different technologies. These are the ones I just mentioned, the ones that have been used for the DEEPEST prototype. And we have included there a large number of European hardware technologies. Some of them are listed here. So first of all, the system is cooled, it's a MEGWare cluster, a MEGWare system, which is direct liquid cooled. And they also include an accelerator node, which is selected. It's a new design that is the third result I will present here. As I mentioned, Extol's Fabric Cube network, that's the network selected for the booster, which is also developed in Europe. And attached to the Extol network, there are accelerator devices, the network attached memory, and the global collective engine. Again, specific developments, also European. But as I said, it's impossible to describe all of these in detail, so you just have to choose 3 of them. And the picture that you see here is a picture of the prototype, as I mentioned, from MEGWare. So on the front, you see the cluster, the one that looks, sorry, something went wrong here. I don't know, what did I do? Do you see me, or do you see, now I hope you see the slides?
We see both.
Okay, good. So the cluster or the rack that has a slightly darker blue lights on the middle, this is the data analytics module, and the 3 racks that you see on the back, also with nice blue background, these are the ones from the booster. Okay, second result, very important, is here the software stack that allows us to operate this system as one single machine and to run applications across all modules. The core is the Parastation modulo that contains, for instance, the MPI implementation that allows to distribute MPI codes across gateways and across modules. And also lots of open source elements that then provide a specific additional features. So in principle, the goal here is to give a very close, so basically the standard or the familiar user environment, software environment from an HPC system, but with support for the specific architecture that we have developed. So the programming model is based on MPI, but MPI supporting GPU direct, and also the gateway, that gateways are the ones that bridge between the networks between the modules. And there is also, for instance, OMPS, as you know, is a development from BSC well, it's a kind of an advanced version of OpenMP. Here now has been improved with even more GPU support. Scheduler is very important when you have so heterogeneous resources. So we have extended Slurm, which is not European, but it is on open source development. And it is also, in our case, the resource management that runs on top of the Slurm is PS Slurm, so part of this Parastation modulo from Partech, which is one of our partners. And this allows also, for instance, to integrate shared resources as the network attached memory that I mentioned at the very beginning. Now, also monitoring tools are there. The data center database is a development from LRZ, a partner from the project. We have also file system, BEFS, you probably know it, this European development came out from Fraunhofer Institute in Germany. And then a series of libraries, something, for instance, IO libraries like xionlib, also open source. So lots of things that are put together into a software stack to provide all the functionality needed by the applications that are also participating in the project. And since these 2 results were very general and contain many things, and you are probably now totally lost in between all the things that I tried to select one which is very concrete and very kind of visible. So this one is the accelerated node developed by MEGWare, our integrator. And as you see on the right, this is a double-sized so-called combo node. So that contains so has a place for a CPU and the GPU blades that they are coupled together, of course interconnected, they have communication between each other, and both blades are water cooled, so direct water cooled. You see here the quick connects on the back of the rack of the board. And there is also what is called an energy meter. So there is a specific hardware attached to these 2 devices in order to be able to read the power consumption of each one of the components of this node independently and understand exactly where the energy is being consumed. So this allows you to continuously monitor. This makes the data accessible to the users via, for instance, Slurm, also to the system administrations, which can then decide to prioritize more energy efficient jobs in the system. And the data is, of course, also available through this monitoring database data center from LRZ visualized via Grafana. Forgot to mention direct liquid cooled warm water inlet temperature of up to 55 degrees Celsius. Doesn't require chillers and it's fanless, so it can then the system is then attached to a dry cooler outside of the building for just being cooled with the outside air. So this is a really core technology from Megware, which now within this project, with this node for EPU, also direct liquid cooled, has added an asset to their portfolio. Okay, now go on to the next questions, the TRLs of these three topics. So very quickly, the first one we would say is at least TRL 7. So it has a prototype demonstration, and you see the prototype on the right in an operational environment. So it's in our computer center at Jülich. The software stack, of course, it's a lot of things. So it depends on the element that you are looking at. But in general, I would say that they are all of them, or most of them, with TRL above 8, with the complete system is there and it's qualified. In some of them, the most advanced ones, they are even in TRL 9 with proving on the operational environment. For instance, Parastation Modulo is installed also in our production systems at Jülich. And then the third example, we would say this is also TRL 8 with system prototype demonstration in an operational environment, as it is here part of the system you see on the right. I will go now into the next question, which is actively promoting these products. And there, I think that I address as well how to push them higher into the TRL level, which was actually part of the last question. So the architecture, what we do is we give early access to external users to our prototype. So there will be, of course, this is during the project lifetime, where most of the resources are for the applications involved in the project, but external users can apply also to get into the machine. When the project ends, this can be even extended, and there will be then access for more users. If you are interested, just get back to us. And we will also use this prototype in future research projects. We, of course, do the standard dissemination, press releases, media channels, websites, and we promote the adoption of this concept into the future, into this Euro HPC petascales and pre-exascale systems. And actually, we know that at least 2 of them are going to apply this architecture. And we are also promoting, or we are also involved in a proposal that will use a similar design architecture for a pilot system. Second topic, software. The main approach here, also to bring them to higher TRLs, is to make sure that the extensions of the packages that we have in the project are then integrated into the main branches of these software packets. And they are then distributed by the code owners, which are Partec, Fraunhofer, BSC, Jülich, etc. Some of them are also providing commercial support. So in particular, the companies of Partec and ThinkPark, which is a spin-off company from Fraunhofer. And last but not least, the Megware, the accelerated node, is of course promoting it through the DEEPEST prototype. I have to correct that. It will be then distributed or will be accessible through the early access program, and it is also displayed at exhibitions when Megware is in some conferences like supercomputing or ISC, and of course in the portfolio websites. Who we could collaborate with in Europe? In principle, anybody interested on the different things that we are doing. From the user perspective, praise and the COEs, they are the user communities. They can have access to the prototype and to the environment. We can help them in adapting their code and then share the results that we have had with the current applications. For other projects in Europe and in Euro HPC and also some national initiatives, we are willing to share experience and to promote then the use and the test of the things that we are doing. In the computer centers, well, we are happy that the concept is adopted in other places, and also the hardware and software elements that we are doing here are taken there. And then with the general industry on the software side, so the software industry partners, so if they would like to adapt their packets to also support this kind of architecture, we are very happy to try to collaborate on that. And on the hardware side, also new technologies can be integrated. Last question. I have no idea how much time I have, but probably not much.
Yeah, up actually.
Yes, sorry. Last thing, European sovereignty. So we are doing here the further development of European technologies on the hardware side with MECWare, with Extol, in the software side with Parastation, Modulo, with BGFS, OMS, etc. And also the applications that are involved, which I didn't speak about in this presentation, are of course also European developments. And then one final thing is that the architecture itself is actually also a European development that has been come out from here, from Jülich. And a very interesting thing is that it is allowing to interconnect and to integrate European developments as the ones I mentioned above into an international environment. So you can mix parts that have been developed in Europe with parts that have been developed elsewhere. For instance, we don't have memory development really in Europe, so we need to do this, to take this from abroad. And I think it's important to present European developments as an added value to what is also elsewhere, not specifically as a substitute, but to enhance what is added on top of other things. And I'm done. Sorry for taking longer than expected.
That's no problem, Estella. Thank you very much, Estella. So now we move on to Mont-Blanc. Said, are you ready to share your screen? Said?
Yes.
Okay.
I just have to select.
We can see you.
Okay,
That's
can you hear
thing.
me?
We can hear you. Now we need to see your slides.
Okay, I select the good screen. I hope it's the good one.
Yeah.
Or maybe I'm not at the beginning. Yeah. This is better.
Yeah.
Okay. Okay. Thank you for the invitation. Very happy to present the Mont-Blanc project on behalf of all the Mont-Blanc consortium. So I try to answer the question. First, I'll start with one slide to introduce the project. So Mont-Blanc project is a pioneer in ARM for HPC. So yes, the initial vision was to leverage the mobile technology, very successful from ARM, and to push it into HPC. And it's a very good timing to discuss that because, as you know, the rise of ARM in the server and HPC market has reached a very important peak with the first place in the top 500 system, which is powered by ARM CPU from Fujitsu. Now this project is addressing many topics. It's a co-design project from architecture, software, and hardware development. And I have selected the top results, focusing on the end of the project, so the latest results. And during this last phase, Mont-Blanc project is focusing on processor design and is a kind of forerunner for the European Processor Initiative, which is targeting the next pre-exascale system, European one. Okay, so the first research that I've selected is the in the category of tools and modeling. So the ARM technology that have been selected for HPC is based on the instruction set extension introduced by ARM called Scalable Vector Extension. which is a new vectorization paradigm, which introduce some new new options such as lens agnostic vector units, auto vectorization, and many other optimization. So there is here a need for modeling and simulation framework. So we have leverage on a GEM5 simulation framework with ARM as a partner. We have been able to produce SV-enabled performance model, and this has been used internally in the project for architecture and performance studies, also for libraries, software stack development, and first optimization. And we have been very proud to upstream all these results to the GEM5 community. And as a bonus, we have added a new features on the GEM5 model, which is the power modeling results that you can get some power consumption of your application running on this simulation framework. So I've put the two CPU that will use this SV technology. So you know that Fujitsu has already released the CPU, but the EPI processor, European processor, Cypher has announced that it will be based on ARM cores embedding SV compute units. So it's very important that these tools are available to prepare our next European project and next ARM power system. In terms of promotion, so of course, GEM5 community is a very rich community on ARM developers. We also have the full support of ARM to promote all these tools on their website and all the events that they organize. And we have also organized hackathon and tutorials to expand the user of these tools. Okay, so that's the tools part. Then one very important objective of the Mont-Blanc project, Mont-Blanc 2020 project, is to develop the critical block for developing a system on chip for HPC. So we have selected several IPs that have been developed in the context of the project, and I have selected the network on chip one, which is becoming very key in SoC design, because now we have several challenges in silicon design. We have always latency requirements and throughput requirements by increasing the number of cores as the frequency cannot scale anymore. The pressure is now on the architecture of the SoC, and we have a heterogeneous core to handle. We have a memory bandwidth increase with this new HBM technology, and it put a lot of pressure on the network on chip design. So we have selected a protocol which is CHI, which is a standard ARM protocol, so that our IP can be reused in our other projects. And in terms of TRL level, the idea of Mont-Blanc project is to go to emulation. So in chip design methodology, before going to manufacturing, which is a very huge investment and cost, you emulate your design in FPGA, and you run your application at a lower frequency and on a big rack, but with the exact algorithm and code that you will be implementing in your ISC. So we are at this stage. I put that TRL4, but because it's not a real system, but that's the last step before productization. And the idea is that the European project initiative will be responsible for productizing this IP in their CPU. So they will have to go to the next step of implementing in the real ASIC, manufacturing it and testing on silicon. In terms of promotion, so this is a very specific audience for that target. We are targeting conferences for a SOC designer, such as a DATE, for instance. And we also have an innovative methodology for validation, where we get traces from the GEM5 tools that I just described, and we can have a validation on real workloads from real application. So this is something that Mentor, which is the provider of the emulation platform, find very interesting. So they promote us and they sponsor us for having presentation for their user community. And it's quite a large audience of a SOC designer, not only European, but a very powerful tool for promotion. Okay, and my third top result, so I just a little bit, it's a 3 prototype. So it has always been important in Mont-Blanc project to end the phase with a hardware prototype, which is driving everyone's work, and it's a kind of legacy for the next phase. So the first Mont-Blanc prototype was the first system, HPC system having ARM cores, was based on mobile technology. Then the Mont-Blanc 3 phases ended with a real product that is now in Atos catalog as a HPC system based on Marvel ThunderX2 CPUs. So I put on TL9 because this system was not 100% the one that is commercialized, because we had some additional validation to go to customer, but it's almost TRL10 result for this one. It was a very successful output of the project for everybody. And now we have what we call the demonstrator, which is this big Mentor graphic emulation platform that hosts the code for our system on chip. So several racks, you can emulate a 32-core CPU. Having this SVE extension for HPC optimized instruction, and HBM memory. So this platform is before production. So I put it as a lab level prototype on TL4. And in terms of promoting, I would say that the Dibona platform was very successful because it's an open platform available for academics to have hackathon and develop on ARM-based system for HPC. And Mont-Blanc 2020 SOC demonstrator will be mainly targeting SOC designer, the same ways than the NOC design. Then I have one slide on collaboration. So I'm not sure I was very successful to answer the question, but in terms of collaboration, the Mont-Blanc project has always been very strong in academic industrial collaboration. For the last phase in Mont-Blanc 2020, we have more industrial than academics, and we have 4 SMEs. And I think it's already a good achievement in collaboration. We will be very happy to work with more SMEs, because one of the important outcome is to provide IPs, and these IPs should enable new design, not only processor design, but any SOC design with a European IP. So there is here room for new collaboration for new user of our IPs. Of course, as an industrial, many of the partners are collaborating with their customer for providing products to our existing customers. And the main collaboration we have with another European project is, of course, the European Project Initiative, where I say we have a kind of symbiotic process initiative. Sorry, we have a kind of a symbiotic relationship. So my last slide about European sovereignty. I would say that by design, but the European sovereignty was one of the important part of Mont-Blanc's vision. So it was a part of the objective of the project, and it will be, we hope, highlighted by the EPI project with having European technology inside the European processor, and also with the HPC pilot that we hope will use the Mont-Blanc 2020 IP, but also all the software stack and the tools for the architecture and the software development. I have added another important contribution to the European sovereignty is that while trying to find the partners for this Mont-Blanc 2020 project, so the last phase of the project was more focusing on SoC design. It has been very obvious that we are lacking European ecosystem for SoC design and also for accelerators, because general purpose CPU is very ambitious and not so many players in the world. But in terms of SMEs providing accelerators in AI, for instance, there are a lot of companies in the US or outside of Europe, and one of the weaknesses that we have is that, of course, we don't have any more the manufacturing, but also the IP portfolio that you can find from European provider is very weak. So we will have hope network on chip memory controllers, but still there are a lot of IP missing in I/O, for instance, and not only IPs, but we are lacking skills for the latest silicon technology. So now we have the latest European silicon technology is 28 nanometers, and people experts in 7 nanometers silicon technology are rare, and you have to continue working on this state-of-the-art technology so that we will not losing these important skills in Europe. And my last point is that we are focusing HPC, but for that SoC and European ecosystem accelerator that we want to contribute to, one of the most important market will be the edge market, and one market that is addressed by Mont-Blanc project is automotive market. So we have one of the SMEs, Calray, one of the partners that is focused in this market and is looking at how they can develop an accelerator and connect it to the ARM-based CPU that we are developing in this project. So I hope I answer most of the points. It was not very easy, but that's my last slide, Pascal. I can give you back the
Thank you, Said.
screen.
Thank you very much.
Thank you.
Do we have questions? Marcin, do we have questions? Or Michael, do you have questions?
No, I don't have any questions. We don't have any questions.
Oh.
Well, I would, yeah. So I would have a few questions and maybe a suggestion for a follow-up session. I need to unfortunately step out here in 5 minutes, Pascal.
Yeah, I know.
But let me just phrase the question. So I think these two projects are very interesting. They're very mature in my view. They have different architectural approaches, and it would be very interesting now that we have, let's say, an update on on the key attributes, to talk about, in my view, three things in maybe a follow-up session. First of all, I would like to I suggest that we look at benchmarks. So these architectures are running different applications. They have different software stacks. So what are the benchmarking results? For DEEPEST, this is a very novel architecture. The advantage of that MSA architecture compared to more traditional heterogeneous architectures is what, right? So just from a, let's say, future user perspective, what makes me jump to a DEEPEST or to a Mont-Blanc system in the future, independent of, let's say, the underlying processor structure? That is not so important to the user. Important, I think, is at the end, efficiency, flexibility, performance, of course, power efficiency, and so forth. So benchmarking results will be interesting, number one. Then what is the porting effort from my, let's say, application suite that I'm running on any other systems? I would like to port now my application to both projects. What are the challenges? What are the potential issues, the complexity? And number three of my question would be, what are the supporting tools to make me do this jump smoothly? So I think this deserves another session, and maybe if Estella and Said agree, maybe let's say food for another session in September or October.
Well, that's
yes, I'm
fantastic.
happy
I was
I don't
looking
have
for
to
topics
answer
for our
that in
next
5 seconds.
webinar.
I'm happy
Yeah,
I don't
Pascal,
have to answer that in 5 minutes. Now.
Yeah, there's one question, Pascal, from
Yes.
Nick. Will I read it?
Yeah, please.
So this question goes to the two projects, and it's probably a very broad question. And it goes, could the project presenters, particularly DEEP EST, highlight the benefits of their approach? So this is about the benefits of their approach of the two projects mentioned.
Mm-hmm. So very shortly, what we believe is one of the benefits is that you can match the requirements of your application and of your workflow, specifically for application workflows that do different things across, so pre-processing, simulation, post-processing, and so on. What they can do in our architecture is to map their requirements part of this workflow onto the architecture. So hopefully running most efficiently each part on the hardware where it is, let's say, belonging.
Yes, for Mont-Blanc project, the main driver was power efficiency. We had the objective to increase the performance per watt by using a low power technology from ARM. And I think for Mont-Blanc 2020, we are targeting 20 gigaflop per watt results for the CPU. And we see that with we have a good news from Fujitsu CPU, which is now first also on this flop per watt results using ESV technology. So with our implementation, we hope we can improve that.
Okay, Thank you. There's not a comment as well. This comes from Frank Beitke, and I think it's not a question, it's a comment, but I'm going to read it out and then let's see if somebody can answer that. So you mentioned ARM with SVE quite a lot in the context of the API and EU IP. What about RISC-V and Open ISA in this context going forward? ARM's IP is owned now by the Japanese. So
yes, good question. The current strategy is to have ARM cores as a host and to have an accelerator based on RISC-V because of the software ecosystem maturity on RISC-V, which is not ready for the next pre-exascale pilot system. So the first phase is to have ARM as the base for the general purpose CPU and to introduce RISC-V based accelerators. And if it's successful for the next phase, we will consider, of course, having RISC-V as the main instruction set for the full solution. But it was not possible to introduce a RISC-V CPU for the next pre-exascale system.
Okay, sorry for the mistake. The RISC-V is another RISC-V. I'm just reading very fast. So there's no more questions apart from this too, I presume. So Pascal, do you want to lead forward?
Sorry?
There's no more questions.
No
only
more
these
questions.
Two, so
Okay, and we are running late anyway. So, I just need to thank you all now. Thank you to our attendees. Thank you for your patience. Thank you to all presenters, the ones who had the challenge to do their presentation in 5 minutes, and the other presenters with longer presentations. Thank you very much for being with us. Once you leave today's webinar, you will receive a survey, and we would very much appreciate if you could complete that because it will help us prepare the next webinars. And you will also receive a follow-up email with a link to the recording of the webinar. So on behalf of ETP4HPC and of our presenters, thank you for joining us today and have a great rest of your day. See you in September. Bye-bye.
Bye.
Thanks so much. Goodbye.